41? Anybody before 41?
Nope, 41,
17 and
42.
18? I'll go 17 and 18, I'm okay with that. Okay, determine whether, all right, so 17 and 18. So when we talked about this yesterday, the little trick that we did was that we needed to solve it for y first. So how can I take this and solve it for y?
Y equals.
Add what to the other side?
Add 6x. Or
Can
y
we add
equals
6x instead?
No, wait, add 6x.
Yeah, let's add, you could, I mean, you could subtract y from both sides. It's positive, so you'd have to subtract and then switch it around and it would work out. But I think it's easier to just add the 6x to both sides to start with. So then you get y equals 6x. So direct variation, yes or no?
Yes.
Yes, why?
Because of 1y equals.
Right, because you're just multiplying by 6 each time. Each y equals 6 times whatever x is. So that is a yes. And what is our constant of variation? 6. Okay, so then same thing for number 18. So y plus 3 equals negative 3x. So same thing, we're going to start out by solving for y. What do I do first? Subtract 3 from both sides. Can I subtract the 3 from the minus 3x? No, because they're not like terms. So minus 3x minus 3 just stays as minus 3x minus 3, because one has an x in it and one doesn't, okay? So direct variation, yes or no? No, because of this minus 3 thing, that means it is no, and then we are done. Okay? Jocelyn, does that help?
Yeah.
Okay.
Sorry, we'll start with this.
That's all right. Okay, now what? 41, 42?
Yes. True.
Okay, so 41, they give you just this point, and they say write and graph a direct variation equation that passes through each one of the points. So the direct variation, remember, is that you have to say y equals some number times x. And so for us to come up with this equation, we're going to plug in the numbers that we know and figure out what the missing one is. So where does the 7 go? Is the x, so I'm going to rewrite this as 7k, and the 2 goes in for the y, okay? So how do I solve that for k? Divide both sides by 7. So this is a weird one, but it turns out that my constant of variation is 2/7. So I had a lot of students, I should say a lot, I had a handful of students that looked at this problem and said, there's nothing that you can multiply 7 by to get 2. And they were wrong, because you can multiply it by 2/7. Okay?
I don't know how I did this, but I put k equals 2 over 3 and y equals 2 over 7x.
K equals 2 over 3. I don't know where you get a 3 from.
But I did, I don't know such on that either, but I did get y equals 2x, but it should be k, right?
K equals 2/7, and then so the final answer for this is that y equals 2/7 x. So you were on the right track, but I just don't know where that 3 came from.
Oh, so I did, okay,
Yeah.
I don't know about that, but I did get y equals 2.
Okay, so y equals 2/7 x is your equation, and then now we are asked to graph this, and you can make a quick little sketch of this on your paper. It won't hurt you.
It hurt.
Hurt that person, though. Oh my goodness. Good times. All right, so I'm going to graph y equals 2/7 x. What's the y-intercept? 0. So put a dot at 0. What's the slope? Up 2 over 7. Up 1, 2 over 7. Put a dot there. I'm going to go backwards and go down to back 7. And so there is my pretty graph that goes directly through all 3 of those. Okay? What's going to be true about every graph of direct variation?
It's going to be a function.
They'll all be functions. Good. they're all going to go through the origin because it's just something times x plus 0, okay? So they will all be functions because they're all going to be linear, and they will all go through the origin, okay? Excellent day. So number 42 now?
Yes,
Yes.
Okay, so number 42 now that we've done 41 will be a piece of cake. So we have this point, -3, 14. We're trying to figure out y equals kx. So this is kind of like the old game when you had y equals mx plus b, and you plug in a y, you plug in the slope, you plug in the x, you solve for b. Kara?
So I was totally looking at a different problem.
Oh, is that where you got the 3? Okay.
So I had it right, but I
Okay.
thought I had it.
Good deal. All right, so how do I rewrite this with the numbers that they gave me instead? Good, 14 equals -3k, or not x, k. And then how do I solve that for k? Divide both sides by -3. So k equals -14 thirds, which means my equation is y equals -14 over 3x. Okay? And I'm not going to graph that one because it's going to be a pain to go down 14 and over 3, and I don't want to do it. Draw a line. Goes through the origin. Draw a line. Yeah, 0, 0, 0.
It's just a really, really good one.
What'd you say?
Can you do 46?
I can do 46, yeah. Okay, so they're telling us that it varies directly. We know two values for x and y and another one for y. We have to figure out what x is. What do you want to do? Set it up as a proportion, and it's an awkward proportion because of the fractions, but you can do it. So -5/8 over 2/5 equals, decimals would work also, 3/2 over x. Yeah, decimal is a good way to go. So you could do -0.625 over 0.4 equals 1.5 over x. And that would work the same way. They have it set up though, so it's not too bad. If you cross multiply these, what's 2/5 times 3/2? What happens to the 2's? They cross out, they cancel. So that gives you 3/5. And then what do I do with the last number? When you're solving a proportion, you cross multiply and then you divide. So now I have to go 3/5 divided by -5/8. How do you divide two fractions? Flip it over and multiply. So 3/5 times -8/5. So 3 times -8 is -24. 5 times 5 is 25. So it comes out to be -24 over 5, which if you did it as a decimal is -0.96. Okay? You did totally do, we got the same answer. Did you just set up your proportion differently? Uh-huh. You just have the secret fast way of doing it? Okay.
Nothing I did it all, so that was really confusing.
All right, what else am I doing?
52.
Taking notes. 52, 54, 56, and then we're done?
Yes.
Okay. All right, 52, sports. The number of rotations of the bicycle wheel varies directly as the pedal strokes. Suppose that in the bicycle's lowest gear, 6 pedal strokes, so we go 6 pedals, goes with 357 inches. Did I read that wrong? Oh, okay. In the same gear, how many pedal strokes are needed to move 100 feet? So how many pedal strokes make it feet. So we basically have the same idea as we had on the last problem, because there's a proportion staring us right in the face. But we have one, right, which do you want to change, inches to feet or feet to inches?
Oh.
Change the feet to inches, so 12 times 100 is 1200 inches, and so if you use that instead, then there's your proportion, 6 over x equals 357 over 1200. And I will leave that up to you to solve on your own. How come for y?
So we have to switch them around.
What do you mean you have to switch them around?
Multiply, then
Cross multiply then divide.
yeah.
Because you're not.
What about 10? Oh, wait, no, that's 100, just kidding.
Did you think we were taking fewer pedal strokes to go farther distance? We're not. Okay,
Yeah.
54. So let's say that y varies directly with x. So y equals k to the x. Okay? Or k times x. So if x is doubled, what happens to y? Well, let's pick a number for k. 4. Let's look at the case where k is equal to 4. Right? All right, now give me a number for x. 1. What do you get for y? 4. Let's double that x. What do you get for y? 8. Double that x again. What do you get for 16? What's happening? Nothing? Nothing's happening at all. Yes, as the x's are being multiplied by 2, the y's are being multiplied by 2 also. Okay?
So this is going to multiply by 2.
Yep. Or you say the y's double also.
Wait, what number is this? Oh, I already have that. I just
Oh.
wrote it.
Okay, and then 56 is super duper exciting because you can have not just 2 variables that vary directly, you can have 3.
Wait, what do we put for the people?
Nothing. Yes, you leave it blank, and that is the correct answer. It's a trick question.
Just challenge.
Yes.
Like, that one, it confused me, like, writing it out, but when I looked in the book, I just got it. If I'm on a test, and I don't write it out, and
You're gonna, well, here's the deal, if you're on a test and you don't write it out, if you get it wrong, then you get the whole thing wrong. But if you write it out and get it wrong, then I can kind of look at your work and say, oh, she mostly had this figured out, but then she thought 3 times 8 was 25, and so I'm only going to take out half of it. So it's your, choose your own death. Okay, so this is instead of y equals k times x, it's z equals k times x times y. So let's try some of these. It says the area of a triangle varies jointly with its base and height. What is the constant of variation? So somebody tell me the formula for the area of a triangle. 1/2 base times height. Does this look at all similar to this?
No. Yes.
It does to me. The z and the a match up.
1/2 K.
The x and the b match up. The y and the h match up. So what would our constant of variation be in this case? 1/2.
That's all?
Say 2. Okay, now things get crazy. Suppose q varies jointly with v and s, so that means q equals k times v times s. And q equals 24, so I'm going to plug in 24 for q. When v is 2, so I'm going to plug in 2 for v, and s is 3. So same thing as we were doing with the other problems where we had y equals kx, and we plugged in an x, and we plugged in a y, and figured out what k is. Now you just have 3 numbers to plug in, not a big deal. So what does k equal?
30.
Nope. How'd you get 36?
I know.
Oh, okay.
K equals K.
K equals k, that is correct. That's the
High five.
answer we're looking for, so low 5. What number does k equal?
24.
4. How'd you get 4? Okay, 2 times 3 is 6.
Oh, she's just one.
So 6 times k equals 24. So if you divide both sides by 6, then k equals 4. Okay, so now we can rewrite this as, instead of q equals k times v times s, we can write it as q equals 4 times v times s. Then it says find q when v is 4 and s is 2. So q equals 4 times 4 times 2.
What part C?
Nope, this is still part B. What's 4 times 4 times 2?
32.
Oh, Stacy, you're too smart for this.
I know.
You're almost as smart as Johnson.
Not right.
Okay, so you see what we did there? That's a lot of steps.
Yeah.
First, we plugged in the 3 numbers they gave us to figure out what k was, and then we used the value for k that we figured out and plugged in the 2 new numbers to figure out what q is. All right, and then what kind of craziness happens for part C? Suppose z varies jointly with x and y, so that means we can write z equals k times xy. And x varies directly with w, so that means we can write x equals kw. So I took the first 2 pieces and just translated them into math speak. Z varies jointly with x and y means z equals k times x times y. X varies directly with w means x equals kw, okay? So now we want to show that this means that z also varies jointly with w and y. Does anybody see anything we can do with those 2 equations? Plug it in, good. Since this is what x equals, we can plug that in for this x right there. So I'm going to rewrite this, but instead of writing x, I'm going to write kw. Okay, now you're going to really love this. I'm going to tell you right now that in this case, k squared equals k.
That's stupid. I don't
K is just a number, right? It's just some constant number. So if it's 3, then 3 times 3 just equals another number, but it's still just going to be k. And then times wy, and that is our proof that they vary jointly, because that's what that means.
K is a letter.
Huh?
K is a letter.
K is 11.